Hi, my name is Lance, and today I'm going to talk about my favorite design experience in engineering. It was to design and build a hydraulic press for densifying biomass to make briquettes. So a briquette is basically a fuel log that's made out of woody or agricultural residues. Our objective was to make briquettes and test the material properties such as the strength and durability of the briquettes. In order to do that, first we had to build the machine. It was a rewarding experience because it was challenging to design and build. It's satisfying to know that it's a reliable piece of equipment that gives repeatable and reproducible results, which is critical in research. It was done simply and effectively, which adds to the robustness of the design. From projects and research and my personal interests, I've been able to explore and build on my skill sets. These experiences have further developed my creativity, problem solving, and lateral thinking. When I work on a project, I go through all the facets of the design, from the sketch to the CAD model to the machine shop and to the assembly. Along the way, I try and get people's perspectives. I value people's ideas because they may see something that I don't. By combining their strengths, we're able to reach goals no one could have done alone. Alright, so now I'm going to give you a quick overview of our hydraulic press system. At the top we have the compression cylinder. In the center we have our die assembly, which is attached to the frame. And at the bottom we have our ejection cylinder. Me and a graduate student did the design and calculations for the stress and for the strain in the frame and within the cylinders. To the side here we can see the hydraulic power supply, which has a fixed displacement pump. The difficulty with that was a fixed displacement pump can only give you a fixed pressure. So in order to do that, in order to control the pressure, we put in a needle valve which ran in parallel, and a flow control valve which is in series with the needle valve that controls the pressure to the system. The gray enclosure on the side houses our circuit for the system. And here I'm showing you some valves that actuate our cylinders that are controlled electronically. I did all the designs for the electronics and I linked it with LabVIEW. At the top there is a pressure transducer and the data is stored on the computer through the use of a DAC board. And here we have the Texas Instrument DAC that receives data from the pressure transducer and the power supplies that power the control valves and the pressure transducer. What the pressure transducer does, it receives the pressure from the lines, and we're able to determine what the pressure seen in the compression cylinder is. Lastly, here's a video of the press in action. We have 30 grams of biomass. The compression rod is going to apply 57 kilonewtons of force or 150 megapascals of axial pressure, and we hold it on for a couple seconds to bind everything, and then we eject it. At the top you'll see there's a metal spacer that's used to help in the compaction process, so a seal's not formed around the compression rod. And there's the briquette. Pretty small, but it's pretty solid. Thanks for watching.